Hello everyone. So we'll continue with the problems on development of lateral surfaces. We'll take up problem number 8. So the problem number 8 is on cylinder. So cylinder comes to the prism section, therefore you need to follow parallel line method to draw the development of a cylinder. Prisms and cylinder, parallel line method, pyramids and cone, radial line method. A vertical cylinder of base diameter 45 mm and axis length 60 mm is cut by a plane perpendicular to VP and inclined at 50 degrees to HP. He is passing through the center point of the top face. Draw the development of the lateral surface of the cylinder. This is the problem, and the top view and the front view is already written on the board. A cylinder, in the top view it is look like a circle, and in the front view it will look like a rectangle. The projection of the cylinder will be looking like a rectangle. Okay, so now cylinder, the top view of the cylinder is a circle. As you all know, you have already gone through projections of solids and projections of planes, where to draw the top view and the front view of different positions of the circle, you have divided the circle into 4 equal parts or 8 equal parts or 12 equal parts. So just for the construction purpose, we need to divide the circle into equal number of parts for the construction purpose. Okay. Therefore, for the construction purpose, because circle has got no sides, for the construction purpose we need to have some number of sides. Okay. So I will be dividing this into 8 equal parts now. This 4. So again divided into 4 more. 1, 2, 3, 4, 5, 6, 7, 8. I have divided this into 8 equal parts. Okay, and all are just the construction lines. Therefore, all the construction lines should be thin. Only the circle should be darker. So only this pink color should be darker. All other lines should be thin. And just erase all the extra lines. Now I need to name this. I will start with this side: A, B, C, D, E, F, G and H. Name all the sides: A, B, C, D, F, G, H. Now just take the projectors out there. Take the projectors to help in the development part. Okay. Now this is the front view, where the height of the cylinder is given as 60 mm and the diameter of the cylinder is given as 45 mm. Okay. Now I need to introduce the section plane now. The section plane is passing through the center point of the top face. It is passing through the center point of the top face. Top face is this one. So the center point is this. Center point of the top face. This is the center point. And the information about the section plane: it is perpendicular to VP and inclined at 50 degrees to HP. Perpendicular to VP, something like this, perpendicular to VP and 50 degrees to HP, and it has to pass through the center point. It will be something like this. Okay. So the section plane will be something like this. This is the section plane. And this is the retained portion of the cylinder, front view of the cylinder, that you must draw the development. So this is the front view of the retained portion of the cylinder. you should not darken these lines because these lines are just the construction lines. Okay, just to enhance the correctness of the curve, we need points. So if the points are there, different points are there, we can join those points for the smooth curve. Okay, for that purpose we have just draw the construction lines by dividing the circle into 8 equal parts. Therefore, you should not darken these lines. Okay. Now again we need to name this. This edge, this particular edge is A dash. This particular edge is B dash in bracket H dash. This edge is C dash in bracket G dash. This is D dash in bracket F dash, and this is E dash. Okay, so this is A dash, A edge, A1, this is BB1, CC1, DD1, EE1, FF1, GG1 and HH1. Here B and H is overlapping, D and F is overlapping, G and C are overlapping. By now, where the section plane cuts the different edges. This section plane is cutting the edge A at this particular point, so this point is called as 1 dash. So 1 dash is the point where the cutting plane or the section plane cuts the edge A dash, A1, A dash, A1 dash, or simply the lateral edge A. So this is 1 dash. Similarly, the point 2 dash is the point where the section plane cuts the lateral edge B or B1. Similarly, this is 3. The cutting plane is not cutting the lateral edges D, E and F because it is just starting with the center point and ending with the left hand extreme edge. Therefore, it is unaltering the lateral edges D, E and F. So this is 3 dash. Again 4 dash is for G. 5 dash is the point where the cutting plane cuts the lateral edge H or H1 lateral edge. That's it. So this is the point where the section plane cuts the lateral edges. Now since it is the case of a cylinder, we need to draw the development using the parallel line method. So I will take the extended line here. I will take the extended line. Like this, and you can leave the convenient distance between the first or the front view and the development. So leave the convenient distance between these two. Now the length of the development. If it is a square, then you will be having 4 sides, 4 into the side dimension, you will get the length. Or if it is pentagon, 5 into the length, like that. So since it is circle, you will not get any edges. Since it is circle, you need to consider the perimeter or the pi into d. So pi d you must consider as the length. So this is pi into d. That will be pi into 45. Since here the diameter is 45, it is pi into 45. Whatever may be the pi into 45, you just close the development length. Okay. Now this pi into d, you need to divide with 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. You need to divide this also into 8 equal parts. Now how to divide this into 8 equal parts? To divide any line into 8 equal parts, if it is comes as fraction, it will be difficult to divide the line by taking the compass if it is having the fraction. Okay, maybe 12.8, 12.75, it is difficult to have the divisions like this. So mathematically or geometric way of dividing a line into equal parts is this one. You just concentrate here. Select this particular point, draw a line with any acute angle. Draw a line with any acute angle. Acute angle means less than 90 degree. Any acute angle. So I am drawing a line here with any acute angle like this. Now take the compass, any distance. In your compass, take any distance. Okay? Select this point, you just cut. That is the first division. With the same division, keep on continuing 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Keep on continuing like that. So this is one division, second, third, fourth, fifth, sixth, seventh, eighth division. So that 8th division end up with this. So just erase the extra line. Now take the scale, select this point, join this point with the end, this end. Okay? From here, I'll just erase this. Okay? Now just join this. With a straight line. Something like this. Join something like this. Now keep the scale on this particular point. Draw a line which is parallel to this line. Parallel to this particular line. Which will be something like this. Okay. Similarly, draw a line parallel to this line from this point. This leads to this particular point. Similarly, from this point, draw a line parallel. From this point, draw a line parallel. From this point, draw a line parallel. Again, from this point, draw a parallel line. From this point, draw a parallel line. Okay. So wherever these lines cut the length, so this is one of the division line, and similarly this is another division line, this is another division line. This so you need to divide into 8 equal parts. This is another division line. So this is the geometrical way of dividing a line into equal number of parts. Line into equal number of parts. Okay? I will just explain once again. Take any acute angle and take your compass, take any division, cut 8 division. Then from the end, you just join end with that particular end. And keep on drawing the parallel lines with these division lines. Wherever those parallel lines cuts this particular line, that is the division of this particular development. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So where this is A, edge A, B, C, D, E, F, G, H and A. Now just try to transfer the distance. 1 dash is the point where the section plane cuts the edge A, lateral edge A. So transfer this one, 1 dash here. Similarly, A dash is here also, 1 dash. Similarly, 2 dash is the point where the section plane cuts the lateral edge B. This is 2 dash. Similarly, at the same point, this section plane cuts the lateral edge H. So transfer this distance to H also. This is 5 dash. And this is 3 dash, which is C and G. This is 3 dash. And this is 4 dash. Okay. Now you need to join all the lines to obtain the development. So starting with this point to 1, 1. Now 1 to 2, here it is not the straight line because this is a square circle. When a circle is cut open and if you just cut open like this, you will find an arc. Instead of straight line, you will find an arc because it is not a edge. It has got circle. It has a circle, it has got the curve. Therefore, you need to draw lines or you need to join 1 to 2 and 2 to 3 with a smooth curve. Something like this. With a smooth curve, you need to join 1 to 2 and 2 to 3. Now from 3 to 4, that is 3 to D, E, F and G. Here edge D, E, F is remain unaltered by the section plane because the section plane only start with this point and end with this. So it is not doing any damage to the lateral edge D, E as well as F. Similarly, from 4 to 5 and 1, again you should not join it by straight line, you should use curve. So draw a smooth curve between this. It should be a smooth curve. Something like this. Then this to this. Again this one. Okay. So this is the development of the set diagram. Now the question is whether to darken these lines. No, because that is not the lines which represents the edge, that is only the construction line. Only for the purpose of this writing the curve, we have divided that into 8 equal parts. It is only the construction line. Those lines do not represent any edges. Only the lines which represents the lateral edges or the base edges are to be drawn with the thick lines. All other lines should be drawn with the thin lines. So this is the development of the set diagram where you can write the dimension. This is pi d divided by 8 and this particular one distance is pi into d. Okay, so this is the development of the set vertical cylinder. Okay, now the next problem, problem number 9, probably the last problem of this module. It's on cone. A cone of base diameter 60 mm. A cone. So cone means again you need to follow radial line method. So I'll repeat. Prisms and cylinders, you should use parallel line method. Pyramids and cone, you should use radial line methods. And when it comes to the radial line method, especially in the case of cone, as I mentioned in the first problem of funnel, the first portion of the funnel is made up of cone. To draw the development of the cone, we need to calculate the angle theta because cone will be having a circle at the bottom. So circle will not be having any edges, therefore we will not get the length or the end point of the curve. Therefore to end the curve of the development we need an angle, therefore we need to calculate the angle here. Fine, we will go back to the problem. A cone of base diameter 60 mm and height 70 mm is resting on its base on HP. It is cut as shown in the following figure. So here cutting section plane or the section plane or the cutting plane is not given, the condition of the cutting plane is not given. Instead directly the front view is given. With the problem itself, the fashion of the front view is given here. We need to draw the development of lateral surface of the remaining portion of the cone. Okay, so this is the front view given along with the problem. This is the retained portion, this is the retained portion, and this is the retained portion. Again, this is the retained portion, and this is the retained portion. Only the pink color lines are the retained portion of the cone to be retained and to be drawn for the development. Okay, this is the cutoff portion. So section plane 1 and 2. There are two section planes here. One is cutting the cone something like this, another is cutting the cone something like this, and you just take off this particular part. Only the retained portion is this amount. Okay, I need to develop this particular one. The dimension is given along with the figure with the problem. This is 38, this is 76, and the height is 70. The diameter is 60. Name is also given A, B, C, and D. So here OA, this is O dash, O dash A dash and O dash C dash is called as generator. Since it is a cone, you will not find lateral edges here because there is no lateral edges in the case of a cone. Therefore, the edge which appears as edge, the line which appears as edge at the outermost end is called as generator in the case of a cone, that you might have studied in the precision of solids. Okay, so this is the front view of the said image. Now to name the point where the section plane cuts the generator, so the generator O dash A dash is cut by the section plane at this point. This point is called as 1 dash. Similarly, the cutting plane is cutting the edge O dash B dash or O dash D dash. It is the edge which is appearing, that's it. It is just a constructional edge. Okay, so this is 2 dash, again 3 dash in bracket, which is for D. The generator O dash C dash remain unchanged because the section plane is not going to do any damage for the generator O dash C dash. Okay, only this point and this point is to be taken care. That means to say only this point and this point is affected by the section plane or the cutting plane. Now we need to draw the development. Before drawing the development, I need to calculate the angle theta. So theta, to calculate angle theta, the formula is capital R, small r divided by capital R into 360, where small r is the radius of the base diagram, which is 30. Because diameter is given as 60, therefore small r is 30, divided by capital R is the length, the true length of the generator. So the true length of the generator is 76.16 multiplied by 360, that is theta. So if you just calculate this, you will get 141.8 degree. This is what the theta you will obtain once you calculate it. If you try to draw to the scale and if you calculate the angle, you will get it something like this. Now the development, select any random point. So since it is a radial line method, you can draw anywhere on the sheet. It is not essentially write it on just beside the front view only. So select any of the point. I will select this particular point. So I will just draw a line here. I will just draw a line. Now I will just select this point as center, this as center, and this as radius. This as radius. I am going to have some curve like this. A curve. Okay, this is a curve with the radius. Radius equal to 76.16. Radius equal to 76.16. Now angle 141.8. Keep a protractor here. Just keep a protractor here like this and measure 141.8. And you just end up this one. So this angle should be 141.8 degree. Or now you need to divide this into number of parts. earlier in the previous problem we have divided the circle into 8 equal parts. We have divided the circle into 8 equal parts in the earlier problem. But look at this problem. In this problem they have given the naming as A dash, B dash, C dash and D dash. Only 4 points are there. A, B, C, D. Only 4 points are there. That means to say they have divided the circle into 4 equal parts. 4 quadrants like that. Okay, 4 equal parts. If you just draw the top view of this, it will come like a circle. That circle, if you divide into 4 equal parts, A, B, C, D, you will get it. Okay, so since they have given A, B, C, D only, it is understood that it is divided into 4 equal parts. So you need to divide this into 4 equal parts. Okay, how to divide this into 4 equal parts? 141.8 is the angle divided by 4. Whatever is the angle, that will be the first division. Okay, similarly you can divide into equal number of parts. So this is the next division, first division. This is the second division. And this is the third division. And this is fourth one. 1, 2, 3, 4. So this is A, B, C, D and A. Okay, so this is O. Now you need to mark the points. And also look at here, this is not a true length, so you need to transfer this distance to here. So you need to select this particular one, the distance 0 to 1, O to 1, O to 1. This is 1 dash. Similarly O to 2, B. This is 2 dash. 2 dash. O to D. Again, O to D, this is 3 dash. Then O to A, and then O to A is 1 dash again. Okay. What about O to C? O to C is remain unchanged, unaltered. So it is not affecting, the section plane is not affecting the generator OC. Okay. Now you need to darken only the retained portion of the said figure. This is the retained portion, 1 to A and 1 to 2. You need to join 1 to 2, and since here it is a cone, if you just cut open the cone, you will find curve, not the straight line. Therefore, you should not join 1 to 2 with the straight line, you should join 1 to 2 with the curve. Therefore, you just have a curve here from 1 to 2, it is a curve. Now 2 to O, it is remain unchanged, unaltered. O to 3, 3 to 1 dash, again curve. It is a curve. 1 to A, straight line. 1 to A is a straight line. Similarly, A to B, B to C, C to D and D to A, you should join with curve only, because it is a cone. You will not find any straight line, any lateral edges, so it is a curve. A to B, B to C, C to D, D to A. Now you can have this particular distance. This particular distance is 141.8 divided by 4, like that. Okay, so this is the development of said problem which is on the cone. Thank you very much.